This is the first in a series of videos on confidence intervals. And in this video what we do is review a lot of topics that are very important that we're going to use in this section. So the first thing we want to do is we want to look at some vocabulary, and specifically we want to think about what is the difference between a parameter and a statistic. Now, a parameter, the key to a parameter is a population value. Another way to say that is it's a true value. Now, oftentimes parameter is not known. In fact, that's why you're doing statistical analysis, to try to estimate it. But the key is a parameter is a true value or a population value. So, for example, if you're studying how much money people made in America, there is an actual true average income of people in the United States. We might not know exactly what that number is, but there is such a number. Another example is, let's say you were studying how tall people were. Well, there is a worldwide average height. And though we don't know exactly what that is, it's true. So those are parameters, population values and true values. Now, statistic. What a statistic is a statistic is derived from a sample. And what it does, so it's a sample value. And it's a sample value that's been calculated to try to give you insight about parameters. And the most common statistic is what's called an estimate. So, for example, let's say there's a true population mean and you wanted to estimate it. That estimate would be a statistic. The two most common statistics we're going to deal with a confidence interval is x bar, the sample mean, and p hat, the sample proportion. So the next thing we want to do is review what we already know about x bar and p hat. Well, let's think about the sample mean. The sample mean, there are certain things we know about it. First of all, the sample mean is unbiased as long as it's derived from a random sample. So it's an unbiased estimator. Another way to say that is that the expected value of x bar will be mu, right? On average, if we took repeated samples, the average of those samples means will be the true population mean. The second thing we know is we know what the standard deviation, we know something about the spread of the estimator, the sample means, and that is sigma x bar will equal to sigma over square root of n. So let's make sure we understand what these mean. Sigma x bar is the standard deviation of the estimator, the sample mean, and that's equal to the population sample mean, the population standard deviation divided by the square root of the sample size. Another way to say that is how unsure or what the spread of an estimator is when it's the sample mean depends on the true randomness in the sample and the sample size. And the third thing we know is that under certain conditions, in other words, and in particular if n is large enough, that is if the sample size is large enough, you will know that the sample mean is distributed normally. And that allows you to do a lot of statistical tests very easily. So it's normally distributed. So we actually tend to write that a certain way. And the way we write that is we go x bar is distributed normally with mean mu and standard deviation sigma over square root of n. That's the way we write it. The second common statistic we're going to use is what's called the sample proportion. This might be an example where, say, you were asked how many people, do you like football or do you not like football? And you're trying to estimate what percentage of Americans like football. So we're going to use as our symbol for that p hat, which is the estimated sample proportion. And there's certain things we know there too. First, it is also unbiased. The second thing is that the standard deviation of p hat will equal to be the square root of p times 1 minus p. where P is the population parameter, and that P hat will be distributed normally. Again, under certain conditions. The way we write that, and let's do the x bar and p hat together. So x bar is normally distributed mean mu, standard deviation sigma over square root of n. And p hat will be normally distributed with mean p and standard deviation the square root of p times 1 minus p. Now something that's really interesting is, let's look at x bar being normally distributed. The key is that due to the central limit theorem, x need not be normally distributed, right? So x could be distributed mu sigma, but not necessarily normally so. And as long as your sample size is large enough, then x bar will be normally distributed. So that should be enough to get us started. And in the next video, we'll do more on confidence intervals.